The floor is yours.
Yeah, thank you. Thank you for the space. Thank you for the space. Thank you, Patricia, Beth, Bobby. As I'm from ESCAS and IP Institute, I might feel a bit home here in TCD. So I choose this topic. We are working in a preparation of a opinion paper about livestock, because that's not should be the picture. Actually, the picture, we need to connect with soil and soil microbiology, microbiota, and the interactions. So more life we have on the grazing system, more sustainable it is. Was difficult to prove, but some universities starting programs, and we are going to see this data here, this where they are more advanced in the studies. And I'm the third generation of cattle rancher. Actually, I'm not full-time researcher. I'm a second profession and almost not remunerate. So I have a farm. I work in a farm with my mom in Brazil. And this is farm's landscape. It's a hilly area, but we introduced silvopastoral. That was my master subject. And you can see the difference between the farms area with the neighbor. The organic matter, the height of the grazing, the trees, and that's what make me very interested. How these connections work, why this kind of grazing here has lower performance, economic and sustainable. And here just one more look from the farm and for the surrounding areas. So I got really intrigued when a jaguar was seen in the farm with a baby, a female with a baby, and we could guess their range because of the shaping nails on the trees, because in the limit of the range, she used it to lie down and she used it to scratch on the trees. And she didn't go after the calf, the cattle. So for me, is that if the predator maximum of the chain is healthy, might the other environmental system as well. So before 2015, I started the work back in 2001, and by 2015 we had accumulated some experience, some recognition, and some publication that are showing over there. And in 2018, I came to do my master in PE. So I need to say that Claudio Pardo and Suzana Pada are a great reference for me. And every time I open the doors, open the US, second time that I'm here. And who brought me here in 2018 was Laurie Cullen. He connect me with PK Nair, agroforestry science, and I came, and we might have done the first publication neutralizing the enteric methane impact of the cattle through the carbon in a soil organic carbon. And now my host is Dr. Binelli in animal science, and Luis Fernando was the the fuel for me to come. He was my supervisor and he gave me strength. And now you are working with 16 researchers in 5 countries, try to show that there are a lot of interactions between the managed animals and the biodiversity, and might be an opportunity to explore. So everything starts with carbon. Carbon is a so simplistic view of the sustainability, but organic matter, vegetation, biomass, carbon, we are talking the same. And as we are talking above soil biomass, below soil biomass, carbonic, carbon trigger the others ecosystem servers for good or for bad. So the historical stocks of soil carbon is one of the major reservoirs of land, global land, and was 2,000 gigatons. And we lost 534 gigatons, and that is responsible for the rising temperature after the industrialization. Amazingly, 25 of the land cover area are grazing lands, natural grazing lands, pasture introduced by the human, and there's a big difference in management. Here you can see above soil and below soil. Here, every hectare is emitting 0.27 megagrams per year, and here is taking off the atmosphere 7.2. And you can see the grass, and you can see the roots. And here is 10 centimeters, 20, 40, 60, 80. And another thing that is a curiosity, that grass is like a tree, but upside down. If you look, tree has 71% above ground and 30% below ground. In grazing areas, 20% you can see, and 80% is below soil. So it's difficult to develop this feeling to connect cattle ranchers with the soil and with the microbiology, but we are on the way. We are going. So from the carbon, we are trying to first time connect this other critical environmental service. So carbon make more roots make more water infiltration, more carbon, more biomass, more carbohydrates. That is the nutrition for the microbiology. So we have more life, and the microbiology pays back with more environmental service and energy conservation. So this is about the paper, and this is about what we are gonna talk today. So is the presentation slide. First, I'm going for what's not working, inefficient grass. Sorry, I should make play. Yeah, no, not important. Because the efficient had microbiology life, and the inefficient was a desert. So that was the intention. And so after we go from these 5 cycles, we can speak more about food web, soil carbon, synergic interactions, and animal performance and ecosystem service. So that's my mission. So first, the impact one. Livestock has a huge impact. Grazing cattle has a huge impact. Everything that human does almost has a great impact. As society, we have all our learnings and lessons. If you want to keep the earth in a good conditions. So gas emissions, cattle from the animal protein is the major, 46 kilos of CO2 per kilo of protein, uh, 550 liters of water per kilo of protein, and pollution. The same land area is the most amazing 200 square meters per kilo. And so we are talking about land cover change. That is the first impact. And we are talking about natural grass or introduced grass that gonna be degraded and might be in a desertification process. So this picture can show literally what I'm talking about. And in Brazil, where I come from, we have a lot introduced pasture that we do tillage, revolving soil, and plant the pasture with a lot of impacts. And amazingly, the life cycle of a pasture with good vitality is 3 to 10 years. So they are renovating the pasture, replanting, and they are not looking to teach the cattle ranchers how to manage their animals for it not occur again. So all money that Brazil invests, all money that Australia invests, US, it's almost the same. Nobody is teaching the cattle ranchers how to improve and diminish the overgrazing. So this is almost the layout. Start a new pasture with 3 years of degradation. There are buried soil areas, new soil removement with atomic bomb of consequence of soil tillage. And some areas we have erosion, and in the drier areas you might have some transition for desertification. So this was one of the greatest source that we found. 2024 just has been published. On this graph, let me help you. Okay. All my searches are here on the below left side. This first graph is grazing intensity. The redder, the more dark, is more intensive the grazing, more heads per hectare, and might be more loss of vitality of the vegetation. Here is the root carbon change, loose root carbon root system, soil carbon. So the purple, the dark purple, is the areas that are matched with the intensity. And here is the author's proposal, optimization grazing with 70% decreasing intensity. So what our problem is like our personal health. If you're sucking up your body, you're gonna be sick. If you're sucking up the pastures, they are gonna lose vitality. So overgrazing, marked by continuous grazing, not rotation, not recovery time, and high density stocks, has decreased the carbon stock 1 meter deeper in the soil for the last 6 years. That's a lot, 1 meter for a pasture. That all this area in dark has 1 meter less carbon soil, and 20 million square kilometers has grazing intensity, and they actually find some good things in this proposal area coming from this lower intensity area. This transition for lower intensity could result in a potential update in vegetation soils, stimulate plant growth, plant allocation of carbon associated with microbes. So now we are seeing the first one publication associating intensive animal management with microbials. So yeah, here is another map for another source. So 25 of the land surface, 7% of the food production area. So 2/3 of the food area are from grazing. And from grazing, 2/3 are going in a not good way. And half have some problems, and this trending is accelerating globally. So United States, Brazil, India, China, Kenya, Tibet, Australia. I think here, I will not be able to see. United Kingdom, yeah, Europe one is in the list. So these two maps gave me the road range for to go further and not to speak only about South America or my country, not just tropical, but we are talking about different climates. So this kind of managed change the natural vocation of grazing lands and animals from cooling to heating. So this is an entropic matrix because the trees here, the grass is here, so we have good aerial biomass, good root biomass, good carbon. As the intensity is growing, we are diminished until bare soils. And here you can see a root in a bad management, animal management, and a root in a good one. So after the animal graze the area, a part of the roots are losing from the original root system and make this organic matter because of intelligence of the vegetation. They don't need this root if the cattle grass the area and they have a small aerial biomass. So we have this proportion, and every time that you give a recovery time for a grazing area, you are adding more organic carbon. We have three major programs in the world. Oklahoma State has 2.6 million in holistic studies award. Oxford University has launched a regenerative lab. Arizona says that Arizona State University has the most comprehensible program because it's so tough to speak that with conventional cattle ranchers, conventional science, conventional research. Is another mindset, but the academic is changing. And if you Google, you're gonna see 20 or 30 programs around the world. So now I'm gonna speak for what's working. We are talking about complex systems, right? Industrial systems from making a car or green revolution from the 1950s are simple systems. They want to be easy to scale, to reproduce, and they want to the systems perform as they want. So there is imposed behavior. So in the green revolution, we subject plants and animals to a desired artificial behavior, to mechanical and chemical tools. So since the plant domestication, animal domestication, we are always saying them what they have to do, where they have to go to the water, to change the paddock, and nature doesn't work like that. That's the difference about complex systems. It's a different neural net, and it mimics nature cycles by favor ecosystem service. So that is what the synergic process is about, and strength the natural cycles. So can be any natural system that current simplistic conventional agricultural approach, simple system. Yeah, I spoke about that already. So first case study, I'm going to present 5 is the bison. For who doesn't know, bison used to be 60 million, almost the grazing heads that cattle in US. They almost were extinct. They were hunted by the ladder or the ladder, and they were run. For the indigenous, doesn't have meat, so they have less food supply, and now they are recovering. And this area is the range of American bison. This is the range in dark when they were diminishing, and now. And some papers are saying that the whole of ruminants is reducing for the society. Society is not giving them the right space. And why they are saying that? If you look at this map, we can see the same. Here is a Yellowstone Park, and we have a breeding range in darker, and we have fall and winter range. So the animals change the areas that they used to stay. And in the same area, they have a movement because they are freely movement of bison. They have that for 50 millions of years, and they could balance their ecosystem by renewing the sickle grass, by grazing or pruning, and stepping on the vegetation and the soil, maintain their own grasslands, because they had the recovery time as they are going for better water, better grass, better vegetation. There was natural intelligence that allowed, if they have a good range as the jaguar that we said, when they come back for the starting point, the grass will be ready for that. So we have much more to learn from nature cycles, making it a paradigm, because there is not a lot of science in that. And we should design food production system support nature intelligence. And the way that we draw a production system now is the way that we impose natural behavior. And the next production system, I hopefully that will be a system designing a multiple elements, like our microbiology in stomach. There's our own brain, and one way to complex work, we need to develop systems like this. So traditional knowledge can be helpful, although it should contemplate more than one point of view. Because when we are seeing what's happened, we have humankind existence, we have animal existence, and we have Earth existence. So many things were good in a good way before the man appear, the humankind appear, development, and many things lose the balance, especially after the Industrial Revolution. So how to mimic bison's behavior? I think less than 1% of the cattle ranchers make grazing plan. So this is matrix of April month and May month. This each one's the paddock. This is when they change the paddock, and now the fourth paddock. Then they move again for the first paddock. And they can make notes. Oh, the first paddock was a lot of biomass when the cattle left. So next time might put 1 or more 2 days. The other one was overgrazed. So I will take 1 or 2 days, make it a looping tool, overlooping tool that you can plan, check, because before I learned that, it's a basic. It was a revolution for me. Claudio Padua left because, oh, this is the revolution from livestock. I thought was algorithmal and something that, and my cattle ranger decides if it's time or if it's not time for cattle to change. And one person decides it's too many inputs for he make sure that he's doing a good job. And that's what I already explained here. The cattle has just left the paddock, so we have a resting time, growing aerial and below biomass. So it reaches mature point, grazing time, and then another cycle here. So we have residual biomass and above ground organic matter. And you have below ground organic matter, more carbohydrates, and more microbiology activity. Because if you have intensive grazing, we don't produce enough biomass for the cattle, for the animals, and no carbohydrate is disposable for the microbiology. So without nutrition, no one survive. So this is a picture just for your mindset. How should graze on good paddock? Should graze homogeneously, because when the cattle leaves, all the graze will get a growth cycle in the same. All graze will provide nutrition. Here is undergraze, not enough animals. Here is selective. Yes, cattle animals are food packers. They choose what they eat, and they might decrease vitality in the best grass, and here overgrazed. And here is how soil bioactivation and food web gets in place. So we have photosynthesis and the grass, more biomass, more photosynthesis, so more roots down deep, less soil compactation, more water infiltration. When you have rain, the more obstacles that the rain has in the way of the river, more slow the water will run off, and more opportunities of infiltration. And also more biomass means less soil temperature. So then we produce more carbohydrates. The microbiology likes the carbohydrates, and the microbiology helps for chemical reactions in the soil for nitrogen, phosphorus, and another areas. And you have 100 million individuals of microbiology in a gram of soil, 2 times more than above soil. So here you can see the full picture of energy conservation, energy balance, and life cycle assessment. This was my PhD research. Back in Brazil, we made qualitative research because who can capture these movements now of the holistic ecosystems are more qualitative research. Quantitative research might work with water, separately with carbon, separately with biology. All results are good, but quantitative has a lot of difficulty to interdisciplinary and make the connections between 1 and 2. And if you stop thinking in grazing, thinking of Amazon forest and how that cycle runs is what I told you. So degradate has the 2 only lives in soil that are most strong, ants and cuttings. Turbine, thank you, Bob. And intermediate grades, you have more 3 species, and sustainable one. Actually, this was a silvopastoral. I'm not saying that this one is the answer, not silvopastoral is the answer. What I'm saying, different production systems, different cattle management has different impacts. And you can see also in the cattle, because if you have microbiology life, you have a lot of holes, and you can see dung beetles. And here it can be like a frisbee. It's so hard that you can throw it. So no microbiology life. So this was the paper that I published. More biomass above soil, less temperature, more water infiltration. There is less 2 to 5 degrees. Can be a fodder bank. This is not tree, this is not grass, it's a fodder bank of protein. And it also can have some bees that doesn't bother the cattle, so you are increasing pollination and you are producing another thing. You are adding value for the production. This paper, also from 2023, talks about vegetation, water infiltration, soil carbon, comparing adaptative multi-paddock to conventional grazing. Adaptative multi-paddock, it's almost to say Voisin system, rotation system. They have intelligence to grazing time, recover time, and see the environmental cycles. So here in this picture, you can see good grass, clean water after rain. So no soil is leaching. Here, intermediate one, berry soils, until you have more structural problem. Here is the silvopastoral, so the rain has a huge options of infiltration. When the rain touches the vegetation, slow down, drop more easily, softly, and can go deeper down. They are measuring water infiltration. So they have a machine that they put on the grass and clock the time that 5 liters, 10 liters takes to go in a conventional and a sustainable one. This Arizona State University in Alberta, Canada. And this is the guy doing the water research. This is the guy doing the carbon research in the soil. And this is the guy doing more carbon, injecting more carbon to preview what will be the behavior and get prepared for more carbon. This is a farm in south of Georgia, white oak pastures. I'm showing this, but so hard that this guy is doing because he has cattle, porks, chicken in the same area, and he uses electric fence. So chicken manure, nitrogen pure, pork manure, phosphato. So after the chicken occupy an area besides the cattle, they move the house of chicken. So they go fertilize in the area, they move the parks in electrical fence, and a lot of grass beef cattle is growing in US. It's a huge business. So we arrive in synergic interactions. So first, animal management enhance the biomass and the carbohydrates production. So there is some carbohydrate for microbiology. Microbiology grows, pays back, facilitating soil chemical reactions, promoting water infiltration, resulting biomass production and animal performance production. We are talking about fertility, birth, weightings, dairy, beef, and further on, these benefits extend for all layers of the food web. So what do we expect? After we calibrate the management, after we calibrate the vegetation before and after the grazing, we work with the carbon, we work with water, carbohydrates, we incentive the biodiversity, might having energy of conservation. So these things starting to go in a spiral improvement. How to do it? It's not that difficult. It should complement the ecoregion specifications, but a plain grazing, recovery time and graze time, best animal practice, anyone can say that, any institute, minimize soil tillage and use of farmer external inputs, used to cow, chemical fertilizing, used to cow herbicides. Now you're saying you have to use all your farm produce, or at least the most you can. We are not radical. You can be a growing upgrade, but the mindset to be independent. If you are independent, you are sustainable. Stimulate biomass, forage diversification, mixed pasture, soil organic matter, food web, adopt individual approach, and implement a feedback loop. It's so difficult for cattle ranchers. I'm a cattle rancher, and agriculture is far away developing technology because the intensity of the capital that are applied. So livestock grazing are more related to conservator, a portfolio with less owner of the land managing, going to look the soil and other things, might in this place run by itself almost. So that's what I said in the previous. After this implement, some synergical ecological functions can be exhibit, enhancing ecosystem service, and paying back reciprocates for animal performance. This is the synergic matrix. incorrect questions lead to inadequate results. I'm here in UF for 8 months to 9 months. Tough questions were made for me, and sometimes the question was not far, and sometimes the person that are doing question doesn't have the right mindset for decision making. So how the global policy governments are dealing with grazing intensity and grazing losing vitality, they are boosting grass system with farm external inputs. As I said, fertilize, herbicides, sowing after soil tillage, often overlook ecological concerns. So it's an economic problem because you spend more money, nature could do that for you, and has a huge footprint. And this is the root of the degradation. The degradation are not the animals. The animals are here before humankind, balancing the grazing lands. When we put the animals in a paddock and which size, when they move, when not to move, how many cattle we're gonna have, here we start to losing the vitality and losing the freely will of the animals that a lot of bibliography is saying 6, 7 days this trending is growing, and a huge portion of degraded grazing areas are not unsuitable for soil-intensive crops. So you can't have another land use for that because it's not fertile for wheat, rice, soybeans, corn. So might be more difficult to a native forest to be introduced in some areas. So there's a millions of money. All the money are saying, oh, we are spending a lot of land for grazing. The grazing is not productive. Let's renew the system in a looping, harmful running cycles. And before the financing, we should train the cattle ranchers to better understand what's going on. We can't keep 10 in 10 years renovating the grazing. This is the good question. Excuse me, Brazilian government, why your agriculture plan that US, why your agriculture money plan doesn't contemplate cattle ranchers training? Why you only incentive replanting, fertilize? I might have my opinion about huge industrial monopoly, but I don't have source until now to say more than a guest. So we are avoiding to running degradation. Sustainable managed grazing systems has yet not received much financial, neither academic support, resulting in scarce scientific data. Necessita additional effort from the academic institution to conduct more surveys focused on grazing multiple ecosystem systems. So a university has to give their position about grazing. Animal science has to do, agronomy science has to do. So subsequently, we can work in more tools for measure. And we are hoping this will be the third green revolution and can involve agroecology, agroforestry, any of one that mimics nature. And here is our paper empirical graphics of environmental footprint, so sustainable one, no grazing, no animal actually is worse than good grazing management, business as usual, and grass boosting. So these all systems are going down, and we would like to give a grazing class like the electronic is in your home. So if you have a measurement tool, you can classify the ones that are working or not working. So we can have more improvement of biodiversity, matching with the consumer industrial behavior, and unlocking financial for the good management, the grazing system. That the financial system doesn't understand what is well-managed grazing system, sustainable grazing system for the ordinary, the conventional one. So my acknowledge start from the 15 co-authors that are supporting me. Without them, I wouldn't be driven for that. I have also, again, Dr. Loisel, Dr. Sampaio, Laura Botero, that's not here, and also for my family that are here, wife and two boys that I'm very proud to speak to them. And yes, thank you.